Welcome! We live in this super connected world, right? We're surrounded by smart devices that seem to work like magic. But have you ever really stopped to wonder how it all works? How is that invisible web that ties our digital lives together actually spun? Well, let's pull back the curtain and find out.
I mean, really think about it for a second. Your watch is syncing your steps to your phone, your smart lights turn on with just your voice, your front door camera sends you an alert when you're miles away. It feels like magic, but it's not. It's just a brilliant, hidden architecture that's working behind the scenes. And that hidden architecture, that's what we're going to unpack today. It has a name, embedded networking. This is the secret language, the set of rules that lets all those billions of tiny, dedicated computers talk to each other, cooperate, and build the smart world we all live in. So here's the game plan for this explainer. We're going to start with the big picture, then dive into the languages and the hardware that speaks them. We'll even see a real-world example in action and wrap it all up with some pro tips. Sound good? Let's jump in. At its heart, embedded networking is the invisible foundation for pretty much everything cool and automated these days. We're talking the Internet of Things, industrial control systems, even the smart gadgets in your own home. It's the critical link that lets these isolated devices share information and actually work together. Without it, your smart speaker is just a paperweight. Now, for any of this communication to actually happen, you need rules. A shared grammar, Otherwise, it's just chaos. In the networking world, that essential rulebook is called the TCP/IP stack. You can think of it as the step-by-step instructions every single device has to follow to send and receive data correctly. Okay, I know this table looks a little intimidating, but the concept is actually pretty simple. The best way to think about it is like a digital postal service. Up at the top, your application writes the letter. That's your data. As that letter moves down each layer, it gets wrapped in new envelopes. The transport layer decides if it needs a signature on delivery. The network layer slaps on the full street address. And finally, the physical layer is the mail truck that actually drives it down the road, or in our world, sends it over an Ethernet cable or through Wi-Fi radio waves. So let's zoom in on that transport layer for a second, because there are two very different ways to send that package, TCP and UDP. TCP is like a phone call. You dial, you wait for the other person to say hello, you have your conversation, and you both say goodbye. It's reliable, you know the message got through, but it takes a little more effort. UDP, on the other hand, is like sending a postcard. You just scribble a message and drop it in the mailbox. It's way faster, super efficient, but there's no guarantee it'll get there, so you have to choose. For a critical firmware update, you absolutely want that phone call. For streaming sensor data really fast, that postcard is perfect. All right, so our data is packaged up and it's addressed. Now we have to decide what kind of conversation we're actually going to have. This is where application protocols come into play. Some are like formal business meetings, and others are more like sending a quick text message. You've got to pick the right style for the right situation.
And here are the three main contenders you'll see out there. HTTP is the one we all know. It's the language of the web. It's great for things like REST APIs, but man, it can be really chatty and heavy. Then you've got MQTT, which is the absolute rock star of the IoT world. It uses a central broker, which makes it super efficient for tons of devices to report in with telemetry, things like temperature data, and for other devices to subscribe to those updates. And CoAP? That's the featherweight champion. It's built on that fast and loose UDP for tiny battery-powered gadgets where every single byte of data matters.
So we've talked about all these rules and languages, but who's actually doing all the talking? Let's meet the hardware, the tiny brains that actually run our connected world. Here are three popular heroes in the embedded space. The STM32 is a total workhorse, fantastic for super reliable wired connections. The ESP32 is a wireless wizard. It has Wi-Fi and Bluetooth built right onto the chip, which is perfect for portable IoT projects. And then you've got the Raspberry Pi, which is basically a full-blown miniature computer, giving you powerful, high-speed networking just like your laptop. And hey, don't let the sight of code intimidate you. This is not a coding tutorial, I promise. I just want to show you how easy this has become. With a modern board like the ESP32, this is literally all it takes to connect to a Wi-Fi network. 3 lines of code. It has never been more accessible to get your ideas online. Okay, that was a lot of theory, I know. We covered the rules, the protocols, the hardware. Now for the fun part. Let's connect all these dots and see how these pieces come together to create a real working application. This picture shows a classic IoT setup. You've got one device, we'll call it the client, that's out in the world gathering information. It then sends that data over the network, could be your Wi-Fi, to another device that's acting as a server or a central hub, ready to receive and process that information. So let's make that real. Imagine an ESP32 with a simple temperature sensor attached. First, it senses the current room temperature. Second, it connects to your Wi-Fi and publishes that reading to a specific MQTT topic, something like living room/temperature. Third, over on the same network, a Raspberry Pi is listening to that exact topic and instantly receives the message. And finally, the Pi logs that temperature reading into a file or a database. And just like that, the data's journey is complete, all in less than a second. So now you have the fundamental building blocks to understand how this all works. To wrap things up, let's go over a few best practices, the little rules of thumb that will help you build connected systems that are robust, reliable, and secure.
Think of this as your personal checklist for success. For your most important devices, give them a permanent home address with a static IP. Plan for things to go wrong by building in automated retries and watchdogs. A watchdog is just a little timer that reboots a device if it becomes unresponsive. Always encrypt your sensitive data. Use buffered writes to store data in memory for a moment before sending so you don't lose it if the connection blips out. And finally, keep an eye on everything to make sure your network stays fast and healthy.
So there you have it. We've pulled back the curtain on the invisible world of embedded networking. You now understand the secret language that these tiny computers use to build our modern smart world. So the only real question left is, what are you going to connect to next? I really hope you enjoyed this deep dive. If you found this explainer useful, it would be awesome if you could hit that like button, share it with someone who might be interested, and of course, subscribe to Endure Darshan Karbikar for more content just like this. Thanks for watching.